Okay. स्क्रीन दिसतोय तुम्हाला?
हो मॅम.
Yes, ma'am.
ओके ओके ओके. So today we are starting the discussion of the new short range technology, that is Z-wave technology. So this Z-wave technology also operates in ISM band, which is a license free band. But instead of using higher frequencies in ISM band, it uses frequencies which are less than 1 gigahertz. Okay. And they are basically developed, these technology. It is basically developed for low bandwidth data communication applications. And all these applications are domestic applications. So for such domestic applications, Z-wave standard has been developed, and this was developed by Sigma Design Incorporation. Okay, so this is also open source implementation. So that is important. Okay, now let us go to specifications of Z-wave. This is a standard which is called as Z-wave aligned standard, or ZAD 12837, or International Telecommunication Union Standard T G.9959. So at least you can remember here Z-wave alliance. Okay. So this Z-wave alliance, even if you don't remember ZAD 12837, that will do. But at least you should know Z-wave alliance standard is used here. And I think you can remember ITU TG.9959. So if you remember this, that is also better for your examination point of view. Then frequency band is important to be remembered, which is less than 1 gigahertz. Remaining numbers which are given in megahertz, that you may not remember, but it is less than 1 gigahertz that you can remember. For Bluetooth, it is greater than 1 gigahertz. Okay, there was some problem with internet, I think. So once again, I'll be sharing screen with you. So we were discussing specifications of Z-wave technology, and one more important specification you can see is its range up to 100 meters. Okay, and application as already mentioned. So some of the key features of Z-wave technology that you have to remember is it is simple and cost-effective solution for domestic applications. Okay, so it is easy to use this Z-wave technology. Configuring of devices using Z-wave technology is easy. So this is important point. It provides a reliable network. That is also important point, and it offers high security, basically, which is required in communication. So you can use this type of technology for banking application, as it is offering high security. Okay, so it is trusted and used across the globe. So it is one popular type of short range communication technology. Okay, so For security purpose, this type of short range communications technology is preferred. So this is what is the important feature of Z-Wave technology. Now, if you see the Z-Wave protocol architecture, just like any other communication technology, it has a similar kind of layers there. Physical layer, MAC layer, transport layer, network layer, and application layer. So this Z-Wave protocol is divided into 5 layers. So let us see here in short, its functioning is given. Okay, so let us discuss each and everything. Z-Wave physical layer. Basically, every physical layer deals with the radio frequency communication. Okay. If you take any wireless type of network, then its physical layer deals with the wireless communication. And if you take a wired network, then physical layer is concerned with the type of the wire, that is channel, that is used to connect the various devices. So the same thing is here in wireless also. So all radio frequency methodologies which are used, they will be in physical layer. So this physical layer will take care of modulation technique that it is using, and as well as coding technique that it is using. And in the frame, it is adding a pattern called as preamble. And this preamble pattern is used for synchronization at receiver. So you have studied in your synchronous type of communication, there must be synchronization between transmitter and receiver, and this synchronization between transmitter is and receiver is carried out with the help of some data which is called as preamble data, and this preamble data is present here, and this preamble data is added by a physical layer of Z-Wave. So this also decides the data rate. So here input configuration of data rate 9.6 or 40 or 100 kbps. These three configurations can be used. Okay, and it also takes care of the radio frequency channel allocation. So as it is dealing with the radio frequency channel, it will decide the modulation, coding scheme, synchronization pattern. Okay, and it decides the transmission rate. So this is what is the function of the physical layer. The next layer above this physical layer is a medium access control level. As its name suggests, it takes care of the slave nodes, and it is basically contained with the collision avoidance and backoff algorithms. Okay, so mainly the some of the network operations, they are carried out in this MAC layer, and these operations are based on various identities called as home ID, node ID, and other parameters which are present in the Z-Wave frame. So we are going to study the structure of the Z-Wave frame ahead. So these operations, home identity, node identity, so these operations are taken care in medium access layer of control layer of the Z-Wave technology. Now, the next layer which is present above this layer is a Z-Wave transport layer, and this particular layer is responsible for packet transmission, and basically it takes care of packet retransmission. Okay. So we have studied different types of error detection and error correction methods. Okay. So a method is there in which the packet is transmitted and it is checked for the error, and if it finds the error has occurred, then it will ask for retransmission of the frame. So if error occurs, the retransmission of the frame will take place. So all this process is carried out in the Z-Wave transport layer. Okay, so the main function of Z-Wave transport layer is retransmission of packet. And second main function is it's a packet acknowledgement. So when package is sent from or transmitted from source to the destination, in response to this reception, the destination must acknowledge. It must send acknowledge signal. So this package acknowledgement is decided by this or carried out by the Z-wave transport layer. Okay. Now, as you can see here, there are different types of frame formats which are used in Z-wave technology. So, transport frame, which is present in the transport layer, it consists of these fields, that is its home identity, its source node identity, the header consists of address, and header and length of the data is also mentioned there, and length of the data it vary from some 0 to x may have different value, and lastly it is appended with the checksum. So checksum is a technique which is used for error detection. So the data packet sum is calculated, and that sum is appended with this frame, and this sum is checked for error. So some at the transmitter and some at the receiver must match. If it is not matching, then the algorithm will decide that error has occurred during the transmission, and it will request the retransmission of the packet. So this is what is happening in Z-wave transport layer. Now here you can observe there are different types of frames which are called as single cast frame, acknowledgement frame, multicast frame, and broadcast frame. So you should know what is meaning of each of these. Okay. So single cast frames are the type of frames which are transmitted to specific Z-wave node only. Okay. So the frame is acknowledged. So when there is single cast transmission, the frame is acknowledged by acknowledgement signal. Okay. And if acknowledgement is lost or damaged, then single cast frame is retransmitted. That means transmission occurs and transmitter must receive acknowledgement signal. If due to some reason the acknowledgement signal is lost or damaged, then in that case transmitter has to retransmit that frame. So this is one retransmission what is called as policy, which is used in Z-wave transport layer. Okay, so when the frames are of single cast frame type, then these frames are transmitted, checked for acknowledgement. If there is no acknowledgement, then single cast frame is retransmitted again. Now, acknowledgement frame type, it is again used for single cast frame. So that is what we have seen here. Okay, so this is used for acknowledgement of the transmission, nothing more than this. Now, multicast frame type. So these frame, as its name suggests, they can be transmitted to more than one node, and maximum 232 nodes can be transmitted. So this is what is multicast frame type of the frame is. This does not support acknowledgement concept. That means if data is transmitted to multiple nodes, then multiple nodes are not going to acknowledge. They are not going to acknowledge the frame. Okay. So as there is no acknowledgement, there is no surety that nodes have received the data, and therefore a multicast frame type is not a reliable kind of communication. So single cast type frame is reliable type of communication. That is what you can say. And next is a broadcast type of frame. These frames are received by all nodes, not particular set of nodes, but all nodes present in the network, they receive the information, or data is transmitted or broadcasted for all the nodes, and this type of frame is called as a broadcast type of frame. Again, as multiple nodes are there, acknowledgement is not used for. Only for single cast frame type, acknowledgements are used. So you have to remember this is important in case of this Z-wave transport layer. Now I think many people have come, so I will take attendance and then we'll continue. Okay.
हॅलो मॅम.
हा बोला.
हा मॅम, ती असाइनमेंट कधी सब अपलोड करायची
हा हा
Moodle-ला?
हा मगाशी झालं त्याच्याबद्दल डिस्कशन. मला ऋषिकेशने पण ते विचारलं. आता मी काय करते, आज किंवा उद्या थोडंसं वर्कआउट करते आणि आपलं जे जुनं Moodle होतं ना, कारण त्यांनी नवीन काही विषय ऍड केलेला दिसत नाही. जुन्यामध्ये E1 आणि E2 आहे आपलं. तर E1 मध्ये E1 चा नवीन पेपर टाकते, E2 मध्ये E2 चा नवीन पेपर टाकते आणि मग त्याच्या खाली मग तुम्हाला हे सगळे आता प्रेझेंटेशन्स पण देऊन टाकते. अभ्यासाला सुरुवात करा तुम्ही. आणि तिथंच एक लिंक फॉर्म करते असाइनमेंटसाठी दोन्हीकडे. म्हणजे आपलं इंटरनल असेसमेंट 5 मार्काचं होऊन जाईल ते. हां, तिथे तुम्ही ते अपलोड करा. तुमच्या झाले का दोन्ही असाइनमेंट्स लिहून?
हो, झाल्यात मॅम.
ओके, गुड. आता इंटरनल परीक्षेसाठी पण तयारी करायला चालू करा. हां, जसं आता मी आज Moodleवर टाकलं ना, ते तुम्हाला प्रेझेंटेशन्स ज्या आहेत त्या सेल्फ एक्सप्लेनेटरी आहेत, त्या नोट्स म्हणून वापरा आणि त्याच्यातूनच तुम्ही परीक्षेची तयारी करा. ओके. इंटरनल एक्झाम आपल्याला घ्यावीच लागेल ना 10 मार्काची. तर त्याच्यासाठी आपण तयार राहूया. जसे जसे चॅप्टर्स होत जातील ते चॅप्टर तुम्ही प्रिपेअर करा आणि जेव्हा आपली एक्झाम इंटरनल एक्झाम कमेन्स होईल तोपर्यंत जेवढे चॅप्टर होतील तेवढे आपण इंटरनलसाठी ठेवूया. म्हणजे तुमची मल्टिपल चॉईसची प्रॅक्टिस पण होईल त्या दृष्टीने. अभ्यासाला सुरुवात करा. ओके. No. The next layer which is present above the transport layer is a Z-wave network layer. So as you can see here, you can see the diagram. So in case of Z-wave networks, there are controllers and slaves. Okay, controllers are masters and slaves are your end nodes or endpoints, you can say. Here you can observe there are two types of controllers. One is called as primary controller and another is called as secondary controller. So primary controller is a master controller and secondary controller is the intermediate router. So this is what is the structure of the Z-wave network. So Z-wave network layer particularly deals with all networking processes. Okay, so it takes part in networking of these devices. Okay, so basically it will control the frame routing from one node to another node. So this is what is an important thing in case of networks, and this is happening in the network layer. Okay, so both controllers as well as slaves, slave nodes, they participate in frame routing. Okay, so basically as you can observe here, the Z-wave network layer has three main important tasks. Transmission of a frame with correct repeater list. Okay, so repeaters are used here and the repeater list must be present there, and transmission of a frame with the correct repeater list must be provided by this network layer. Identification or scanning of the network topology. So it must know which kind of topology is there, and accordingly it has to use the algorithm. And maintenance of the routing table. The routing table is stored in the controller, and according to this routing table only, the routing of the information will take place between the nodes. Okay, So this is important, and this is what is happening in the network layer. So if you take any type of network, it may be wired, it may be wireless. So routing function is carried out in the network layer, and the routing table is maintained in the network layer only. So here, as we have seen, the different frames are there. Single cast frame is there. So this is the frame, one node destination frame with acknowledgement. Okay, so this contains a repeater information. So I have told you, while transmission, if acknowledgement is lost, the transmission is repeated. So this repeater information is stored in the network layer only. So frame is repeated from one repeater to another until it reaches the desired destination. So that is what is carried out here. So if you observe this network here, there are three slaves, and here you can see, suppose if a primary controller want to transmit information, or slave want to transmit information to slave 4, slave 1 to slave 4, then it has to go through two repeaters. So here slave number 2 and slave number 5, they are acting as repeaters. So packet will be delivered from slave number 1 to slave number 2, 2 to 5, and 5 to then 4. So these two nodes, they are acting as repeaters. Okay, and in single cast frame type, suppose slave 1 is transmitting a frame to slave number 2, then slave number 2 must give acknowledgement. So if it gets the acknowledgement, then there will not be retransmission. But if there is no acknowledgement, again retransmission will take place, and this retransmission will take place until it gets the acknowledgement. Now slave 2 will communicate with slave 5 in the same manner, and slave 5 to slave 4 in the same manner. So single cast frame type communication is most reliable type of communication. Here the transmitter is sure that the frame is received at the receiving end. Okay, so for reliable communication, single cast frame type is used in Z-wave type of communication. Okay, so about acknowledgement frame, we have studied already. So here, as again you can see, controller is responsible for maintaining the routing table, and table generally it contains information about all the nodes in the network. Okay, so basically this routing table is built in primary controller. Okay, and this table is built based on the information received from all the nodes. So this is what is happening in the Z-wave network level. So main routing table is maintained by primary controller, and primary controller will be updating this routing table depending on the information which is received from different nodes. So that is what is happening in the Z-wave network layer. So basically routing function is carried out here. Now let us move to the next, which is Z-wave application layer. So above network layer, Z-wave application layer is there. So obviously, this has application program, and this is responsible for execution of commands. So Z-wave network commands can be executed in the application layer. So that is what is the function of the application layer. Okay, so and what this application layer does is it decodes the command, and it provides to the uh, uh, layer below it. Okay, so generally, as I have told you, frame format which is available in the application layer, it consists of the format just like this, that is first bit will indicate whether it is a single cast or multicast or broadcast frame, and if it is broadcast frame, then broadcast frame header must be attached to it, and then which kind of operation is to be carried out, that is mentioned by application command class and application command. So the type of application command is given by application command class, and there comes the application command. and this application command is executed with respect to parameters. So it is just like your instruction that is executed in the microprocessor. Okay, so it has opcode and operand. So opcode is it specifies the type of the function. So here in similar way, application command specifies the type of function, and operand specifies the uh, uh, fields on which this operation has to be performed. Okay, so here also some parameters are mentioned over which this operation can be performed. So it has variable length. Okay, so different variable lengths given here are from 00 hexadecimal to 1F hexadecimal. This is a command class reserved for zwave protocol, and 20 hexadecimal to FF hexadecimal. This command class is reserved for zwave application. So for application, you have to use address from 20 hexadecimal to FF hexadecimal, and zwave protocol itself, it uses address starting from 00 hexadecimal to 1F hexadecimal. So user has to use the addresses ranging from 20 hexadecimal to 20 hexadecimal to FF hexadecimal. Okay. Why it is not working? Okay. Uh, Now, let us go to the applications of Z-Wave technology. So it is very interesting to see the applications of the Z-Wave technology. They are used widely around the globe. So first application you can observe here is a smart hub. Okay. So these smart hubs are central controlling unit of smart applications, you can say. Okay. So if you have smart home application, then the central unit which controls these various smart home applications is called as smart hub. So to develop such a smart hub, Z-Wave technology is suitable and it is used. Okay, so nowadays such smart home applications are widely used, and these smart hubs they are connected with Z-Wave, and then they can be connected to other internet networks, like it can be connected to Ethernet port or Wi-Fi port. Hmm? And from that the internet is accessed. So uh, this is the way in which the smart homes are designed. So this is one of the applications. Then again, coming to you can say this is a subcategory of smart home, or even smart lighting can be used anywhere. You might have seen such applications in advertisements, isn't it? So intensity of light can be wirelessly controlled. Okay, they can be controlled using mobile phone app. So all these things are possible by using smart lighting system. And these smart lighting system provides control through your mobile. They provide automation, and basically they are used to save energy. So this is important. And to develop such smart lighting applications which implement Internet of Things, using Internet of Things, such applications are developed, and these applications use Z-Wave technology for short range communication and network formation. Now, third application you can observe here is a smart lock. Okay, so Z-Wave technology offers a smart lock. Uh, Under this smart access control solution, it will also come. And in smart access solution, fingerprint scanners are used. So access is allowed through fingerprint scanning. Okay, and for this, Z-Wave technology is used, and it is suitable for this. Then smart sensors are there, and these smart sensors are important part of your smart home and the Internet of Thing applications. So these smart sensors, they use Z-wave technology. Okay. For example, thermostats to control temperature, humidity sensors are used, proximity sensors are used. That means proximity means sensing the presence. So for proximity sensors, even RFID tags, motion detectors, water level controllers, flood sensors, smoke sensors, gas sensors, all these sensors, if they are smart, then they are containing the Z-wave technology, and they can be added to Internet of Thing applications. So, smart sensor technology is this includes Z-wave short-range communication technology. Now here you can observe smart home automation. Okay, advanced home automation solutions, they are provided here. So here you can observe number of devices. They are in a wireless network, and they can be controlled by using mobile phone. Okay, and again this is implemented through smartphone apps. So for this type of technology, Z-wave short-range communication is used. Okay, so here you can observe many things. Then for security alarms, for voice-controlled applications, there are many voice-controlled applications. Water management system, smart energy management system, even smart USB is used nowadays. So in all these applications, the Z-wave technology has been widely used. Okay. So now with this, we have finished the Z-wave technology, and now let us move to the next thing. Can you observe something on the screen?
Yes,
Yes.
ma'am.
What it is? Read it out.
GPS, Global Positioning System.
Yes. Whether you are using this
Yes, ma'am.
for what?
For navigation.
What is meaning of that? Finding a route using a map, isn't it? Is it or not?
Yes,
Find,
ma'am.
finding a location, position, and navigation. So these are two important applications of global positioning system. And this global positioning system we are going to study in short. Okay. So basically, this makes use of satellite. Okay, and this is a real-time system, and it is, as you can see, integral part of most of the applications, and very important for mobility. Okay, and this uh, is made possible by using satellites, and as much as 24 satellites, or sometimes 40 satellites, depending on the country, how many satellites are used. Okay, so number of satellites are used to form this type of GPS system. Okay, constellation of satellites is formed, and this constellation of satellite is used to find the location and the distance. Okay, so vast amount of calculations are carried out, which depends on the time, and exact synchronization is required, and using all these things, the position, location is calculated, and navigation is provided. So what you have at your end is GPS receiver. So apart from this GPS receiver, other elements are also there. And what are these elements? Those you can observe here. Basically, GPS system consists of three segments. These segments are space segment, control segment, and user segment. So as you can observe in the picture, the space segment is nothing but the satellites which are present and which are used to provide this service. Control segment which is present on Earth, okay, and sometimes it is also called as a ground station. And third is user segment, which is with you. It is nothing but a GPS receiver. Okay, so kind of the device that looks like mobile phone. Even it is present in mobile phone. Okay, so these are what are the elements of the GPS system: space segment, control segment or ground station, and user segment or GPS receiver. So in short, we are going to